Hi everyone, this is a quick review of the lesson we did about properties the other day. I'm going to talk about the four properties that we discussed: commutative, associative, identity, and inverse. The first property we talked about was the commutative property. And the thing about the commutative property is that it's about order. For example, if I do 4 plus 5, I get 9. But if I do 5 plus 4, I also get 9. So in other words, 4 plus 5 is equal to 5 plus 4. The order that I add things together doesn't change my sum. So in other words, x plus y is equal to y plus x. I can change the order. It's totally going to be okay. Likewise, if I do multiplication, if I do 4 times 5, I get 20. If I do 5 times 4, I also get 20. So in other words, 4 times 5 is the same thing as 5 times 4. The order that I multiply things together, whether I do x times y or I do y times x, doesn't matter. I get the same answer when I'm done. So commutative property is about order. The second property that we talked about was the associative property. Well, let me get this all set here. So the second property that we talked about was the associative property. And the associative property is about grouping. How do we group things together? How do we use our grouping symbols? So in a very basic example, right, if I do 3 plus 2 plus 4, I should get the same thing as, well, I should get the same thing as 3 plus 2 plus 4. So let's see what happens. So if I do my order of operations, I've got to do this first. So 3 plus, and then 2 plus 4, that's 6, right? And then when I do my addition, I get 9. Now I should get 9 here. So I do my order of operations first. I do 3 plus 2, and I get 5. But then, and then I use my plus 4 here, and when I add them together, I get 9. So the way that I grouped things together didn't change my answer in the end. So in mathematics language, I can basically say 3 plus 2 plus 4 is the same thing as 3 plus 2 plus 4. Notice that the terms in the problem didn't change their order, right? So in other words, I can do x plus y plus z is equal to x plus y, and together as a group, plus z, right? So the order that I did things didn't change. This also works for multiplication. So this is associative property again. And it works for multiplication as well. If I do 3 times 2 times 5, and I do my order of operations, I'll do my parentheses first, we get 3 times 10, which gives me 30. Now if I move the parentheses and I shift it over and do 3 times 2 times 5, I should also get 30. And when I do 3 times 2, I get 6. So 6 times 5 gives me 30. So I get the same answer in the end. So in other words, 3 times 2 times 5 is the same thing as 3 times 2 times 5. Math language, we would say x times y times z is equal to x times y times z, right? So the terms actually didn't change their order at all. That would be commutative property. Here, the parentheses are around the yz. Here, the parentheses are around the x and the y. Here, the parentheses are around the 2 and the 5. Here, they're around the 3 and the 2. But it doesn't change my answer when it's over. The next property that we're going to talk about is the identity property. Identity property is about things remaining the same. With addition, that means that we're adding things to 0. If I add 3 plus 0, I get 3. If I add 0 plus negative 2, I get negative 2. If I do x plus 0, I get x. Likewise, well, similarly with multiplication, it's about multiplying times 1. So if I do 3 times 1, I get 3. If I do 1 times negative 2, I get negative 2. So any number times 1 is itself. That's the identity property. The last property that we talked about is the inverse property. And the inverse property requires you, for the multiplication anyway, to know a little bit about multiplying with fractions. Inverse is primarily used for canceling out, right? We talk about canceling out when we solve equations. So for addition, that means when I take a number and I add it to its opposite, they cancel out. I get 0. If I do negative 2 plus 2, I get 0. If I do 7 minus 7, I get 0. So any number plus its opposite will always give me 0. Now for multiplication, it's a little bit more complicated. Just a little bit more complicated. For example, if we do 3 times 1/3, well, remember that we can always write a fraction. I'm going to, let's see. I'm going to erase this 3 here real quick. I can always write a fraction, a whole number as a fraction. So in other words, 3 could be written as 3 over 1. And when we multiply our fractions together, we do the numerators times the denominators, we get 3 over 3, and we get 1. So if I do 1/7 times 7, that's really 1/7 times 7 over 1, which is really 7 over 7, which is really 1. Maybe I should have done that in a different color so that I can make it stand out a little bit better. But I'll do another one. If I do 4 times 1/4, we get 4 over 1 times 1 over 4, which is 4 over 4, which is 1. So what we're saying here with inverse property for multiplication is any number like 2/3 times its reciprocal, in this case 3/2, always gives us 1. That even works with negative numbers. Negative 3/5 times negative 5/3 will give us a positive 15 over 15, which equals 1. So in math language, we would say a number divided by another number, and then we multiply it by its reciprocal. We'll always get 1. Always, okay? We do have to be careful here and say that x can't be 0 and y can't be 0. We're not allowed to divide by 0. So those are the 4 properties that we discussed. So we talked about, again, just to summarize, we talked about commutative, which is about order. We talked about associative, which is about grouping. We talked about identity, where things stay the same. And we talked about inverse, where things cancel or cancel out.